Hello, my fellow YouTubers. This is Roy back again. Let's get to it. Got two nice fresh coils. Got them wound separately. Not that it matters at this moment, but that's wound to where this is in the north, so it's wound clockwise. This is wound counterclockwise, so it's south. And I got the volt digital meter hooked up. And I got, let's go ahead and hook up these two batteries. We're going to be putting 24 volts in this center, and these batteries are not the best to charge. Let's see what we have. Meter turns on at 3 volts. So we probably have a lot more current than voltage right now, because these are 16 gauge wire, 300 turns. They're both 0.9 ohms, so they're almost 1 ohm each. You can see the voltmeter's dropping down, but it's got some great response going on between the iron and the, remember, every time a pole passes one of these coils, it's flipping the poles, so it's pulling itself. It's sort of creating its own futuristic dipole to where it's pulling itself to the dipole. You can hear this thing shaking right now. So let's do the same thing without it being connected in the center. Okay, we're disconnected. And let's do the same thing now. Let's get it going. See how long before the blue light comes on. Coming on now. I gotta spin it extra fast, and it's barely coming on. But I can tell you right now, the wheel just took off on its own. Seems like it's going faster because it's having somewhat of a load on it, because it takes 3 volts to get that digital thing to go on. And now I can hear it's slowed down. So having a load outside of it sort of makes the reaction between those right there a lot more responsive. I mean, it's still kicking ass, but if you see it's slowing down. But let's get it going to where the light was going on, where that load was coming into play. Right there. There's your load. And look at it. It seems with the load going, bouncing, it seems to be going real fast, like faster. And then as the load dissipates, it's where it catches up to itself. You see that? So the load right now is minimal, and I can already tell you it's slowing down. But at that point, that one juncture where that load, so we can look into balancing the load. Balancing, see, that's you gotta see what that load is. Look at it, it's taking off. It's taking off. It's taking off, it's going faster. Because of the load. Look, the load's still staying. Now it's dissipating. Food for thought. Leave your comments. More coils to go. More coils to go. Let's see that take off one more time. That was pretty damn cool. So we got to get it to where the load kicks on. That's taking off right now. That's with 2 batteries in this damn center. Look at that thing. It's still flying faster. Load went down, so did it. You can tell. All right, guys. Load to be. So to be or not to be, the load. So once these coils are all the way around, we're going to start to see what, it's a balancing act. Because they'll each PMH, two sections will have a capacitor. So the relationship between the capacitor and the two coils will be a tank circuit. The tank circuit will charge up. When it's charged, it'll allow this PMH to be its own pole with a fight to change. And with it being a fight to change, that it's going to lag, and it's also going to create a pole, same pole to same pole situation, to where it forces out the extra electrons because of the saturation is at its point, and it has to go elsewhere. And that's where I was seeing the peaks on the oscilloscope and that analog meter show up. Leave your comments. You'll see now with that one set of coils there, how it pulls itself. Peace out. Leave your comments.